Welcome back. Now we are going to look at the green example. Let's write down the numbers, starting from 69. Okay. First we need to generate a random number to find our starting cell. So 69 mod 16 5. So our starting cell is going to be this. I will mark it as V, which means visited, because it is important. We'll now create a list A consisting of every unvisited cell which are all adjacent to some of the visited cell. Since this is the only visited cell, our list consists of 1, 4, 6, 9. And yeah, cell ordered in reading order as I did. Now we're going to generate a new number using the number of cells in A, which is 4. So 48 mod 4 is 0, so that means we're going to look at the first cell. I mean zeros, but you know what I mean. So cell number 1. And let this cell be called C. Now we're going to look how many visited cells are adjacent to C. In our case, it is only 1. So if it would, for example, be 3, for example, we would look at these all cells visited adjacent, and starting from north, going clockwise, we would number them in order. So this would be 0th, 1st, 2nd. Then we would generate a new random number. So number 10 modulo 3 it would be, and so it would be 1, so 0, 1. So that means we would then make the wall between these two cells possible. But since we only have one visited cell adjacent to cell C, this is the only possibility here, this exact cell, so we're going to delete the wall between them. And don't forget to move the pointer. And now we repeat steps 2 to 4. Since these two cells are now visited, our list A now consists of this, and this, which are 0, 2, 4, 6, 9. Okay, 99 mod 5 is 4, which means we're going to look at this cell. Since between this cell and since it's only one adjacent visited cell to this cell C, this is the only possibility, so we remove the wall between two of them and make the cell V again. Okay, now don't forget that technically had to generate a new number, although we had only one possibility, move the pointer. Okay, new list A is 0, 2, 4, 6, 8, 10, 13. Or 6, 8, and 13. Okay, 69 mod 7 is 6. So it's cell number 13, which is this one. Once again, the only adjacent visited cell is this one. So we're going to remove this wall. And remove the pointer. Even though we had one possibility, we still move the pointer. Okay, now we have 0, 2, 4, 6, 8, 10, 12, 14. 96 mod 8 is 0, so it's this one. Cell 0 also has only one adjacent visited cell, so that means we're removing this wall. Moving pointer twice. Okay, now we still have 2, 4, 6, 8, 10, 12, 14. 58 modulo 7 is going to be 2, so it's cell 6. This cell also has only one adjacent visited cell, so we remove the wall between these two cells and move the pointer twice. 48. Okay. Okay. Now we have this cell, which is 2, 4, 7 instead of 6, 8, 10, 20, 14. Okay. 48 modulo 7 is 6. Taking a look at 14. 14 is this one. Also only one possibility. So removing the wall between these two cells. Okay. Now we have 15 instead of 14. Let's make sure 2, 4, 7, 8, 10, 12, 15. Okay, 99 mod 7 is 1. Taking a look at 4. And now we have 2 adjacent visited cells. So let's take a look. 74 modulo 2 is going to be 0. And since we're starting from the north, this is going to be 0, this is first. So we're deleting the wall between these two cells, which is going to be this one. Okay, now we remove cell 4. And double checking. We have 2, 7, 8, 10, 12, 15. Okay, 69 mod 6 is 3, so 0, 1, 2, 3. Taking a look at 10. 10 has 3 adjacent visited cells. So 30 mod 3 is 0, which means so this would be 0, this would be 1, this would be 2. So which means we're going to delete the cell between these two. And this is this one. Okay, now we have 2, 7, 8, 11. It's 11, 12, 15. And 96 mod 6 is 0, so taking a look at second cell. 2 has 2 adjacent visited cells. So 16 mod 2 is 0, which means this is 0, this is 1, so we're deleting the wall between these two. Okay, and now instead of 2 we have 3. Now every remaining wall is okay, 3, 7, 8, 11, 12, 15. Yep. 58 mod 6 is 4. 0, 1, 2, 3, 4 is 12. Taking a look at this cell, it only has one adjacent visited cell. So we're going to remove this wall. and move the pointer twice. Okay, removed 12, 3, 7, 8, 11, 15. Okay, 48 mod 5 is 3, 0, 1, 2, 3 is 11. 11 only has one visited cell adjacent to it, so that means we're removing this wall and moving the pointer. 3, 7, 8, 15. Okay. 99 mod 4 is 3, so taking a look at 15. 15 has 2 adjacent cells, so we're taking 74 mod 2, which is 0. This is 0, this is first, so we're removing the wall between these two. So this wall. 69 mod 3 is 0, so we're taking a look at third wall. It has third cell, it has only one adjacent visited cell, so we're removing this wall, removing the pointer. Okay, 96 mod 2 is 0, so we're taking a look at 7th wall. It has 3 adjacent visited cells. 16 mod 3 is 1, so 0, 1, 2, so this one. Between these two is this wall. 50, okay, and the last remaining cell is 8. So technically still mod 1, so we remove the pointer again. Each cell has 3 adjacent visited cells, so 69 mod 1 or mod 3 is 0, so this is 0, this is 1, this is 2, so that means between these two we delete the wall. Now every cell has been visited, and we have a generated maze. Okay, going from white to green. Okay. Left, down, down, right. That was the